We are changing topics a little bit, and we're now not going to be talking about standing waves, but we're going to be talking about interference. So interference is going to come from two traveling waves that are moving in the same direction. So one of the things that's a little bit different about this is that when we talked about getting standing waves, they were actually traveling initially in opposite directions or reflecting. So for right now, think about two waves traveling in the same direction. For the simplicity of analysis, we're going to consider the same frequency, wavelength, and amplitude. So that's going to be an assumption of all of the math we're doing right now. Now, obviously, we can combine together waves that don't have the same frequency or wavelength or amplitude, and you're going to get slightly different phenomena if you do that. So right now, just for simplicity's sake, assume that we're talking about two waves that are really the same. And to really do this math, we're going to be talking about phase differences. So phase, remember, is really that argument that was within your traveling wave. So that's where we're trying to go with this. So the basic idea when we're doing this is that we have some point of detection that we want to understand what is the interference at this point. We have two sources of waves. Again, this might be sound, this might be light. And we're going to think about these, for instance, speakers being in two different positions. So notice that we have x1 and x2 corresponding to the different distances between our point of detection and the source. Now notice that these two waves look like they have the same wavelength. If they're both sound, they have the same speed. That means they would have the same frequency. And notice that it looks like they're completely out of phase. So we're going to call this destructive interference. So constructive interference means that your two waves line up perfectly. And so there's a couple of ways that that could happen. And so two examples, one with light, and notice that for light, in order to have one laser not block the other, we're going to use like these mirrors that are partially transmitting and partially reflecting. So in this case, we have two different lasers. They're producing the same wavelength of light, bounce off the mirror so that they're traveling together, and we see that their peaks line up, their crests line up. So this was going to be constructive interference. Again, this can also happen with sound, and what we're going to get then is a superposition of these two waves where if your original amplitude of one of them was A, your amplitude is now 2A, but it looks like a sine wave. And the speed of this wave, keeping in mind that again these are traveling waves and not standing waves, the wave speed here is the same wave speed as it was there, since this is all sound. The wavelength is the same, the frequency is the same. So the only thing you've actually changed in the case of constructive interference is in fact what the amplitude is. So destructive interference, this is the picture I showed you before, but now this is the result. Because one wave is canceling the other in every single point in space, you actually get zero. You have a wave now with zero amplitude. And again, it's helpful sometimes to draw that equilibrium line to see that there's a symmetry. For every point down in one spot, there's a point up from the other. So these always are going to sum to zero. So we would call this 180 degrees or pi radians out of phase, right? One's going down while these other is going up. Now we would also call this perfect or perfectly destructive interference. Typically we use constructive interference to mean perfectly constructive, exactly in phase. And when we say destructive interference, we often mean perfectly destructive. But I'll try to be specific because these are in fact two special cases, and you can imagine that everything else happens for something in between. So when we're talking here about destructive interference, we're talking about the special case where it's perfectly destructive so that you get exactly zero out.